Imagine waking up tomorrow. Your phone has no signal. The internet is gone. Airplanes are grounded. Entire cities are without electricity. Not for a few minutes, but for weeks or even months. And the cause? A massive solar storm from the sun. The sun looks calm from Earth, but in reality, it's a gigantic ball of explosive energy constantly sending radiation into space. Most of the time, Earth's magnetic field protects us. But what if a truly massive solar storm hit our planet directly? Let's find out. Before we imagine what a massive solar storm could do to Earth, we first need to understand what a solar storm actually is. Our sun may look calm from 150 million kilometers away, a bright, steady light in the sky. But in reality, the sun is an extremely violent and active star. Deep inside the sun, nuclear reactions release unimaginable amounts of energy. That energy rises through the surface and twists the sun's magnetic field into enormous knots. Eventually, those magnetic knots snap, and when they do, the sun releases a sudden burst of energy called a solar flare. A solar flare is one of the most powerful explosions in the entire solar system. In just a few minutes, it can release as much energy as billions of nuclear bombs exploding at once. The flare sends intense radiation racing through space at the speed of light. If Earth happens to be facing the sun at that moment, this radiation can reach our planet in about 8 minutes. But sometimes a solar flare is only the beginning. Occasionally, the sun releases something even more dramatic. A coronal mass ejection, often called a CME. Imagine the sun throwing a gigantic cloud of superheated plasma into space. Billions of tons of charged particles wrapped in powerful magnetic fields. This enormous cloud expands outward like a cosmic shock wave, traveling millions of kilometers per hour. If the CME is aimed directly at Earth, the cloud will continue racing through space for 1 to 3 days, until it finally reaches our planet. And when that happens, billions of charged particles collide with Earth's magnetic field. Most of the time, our planet's magnetic shield protects us. But when the storm is powerful enough, the interaction between the sun and Earth can create a planet-wide magnetic disturbance. This is what scientists call a solar storm. And if the storm is strong enough, the effects can reach far beyond the sky, all the way into the technology that powers our modern world. Luckily for us, Earth is not completely exposed to the violence of the sun. Our planet has a powerful natural shield, an invisible force known as Earth's magnetic field. Deep beneath our feet, far below the crust, Earth's outer core is made of liquid iron and nickel, constantly moving and swirling. These massive flows of molten metal act like a giant generator, creating a magnetic field that surrounds the entire planet. This field stretches far into space, forming a protective region called the magnetosphere. You can imagine it as a gigantic invisible bubble surrounding Earth. When streams of charged particles from the sun rush toward our planet, this magnetic bubble deflects most of them away, guiding them around Earth instead of letting them crash directly into the surface. Without this protection, the constant radiation from the sun would slowly strip away our atmosphere, and life on Earth would look very different. But even when the magnetic field protects us, the interaction between solar particles and the magnetosphere can create something beautiful. When some of those charged particles slip through near the poles, they collide with atoms in Earth's upper atmosphere. These collisions release bursts of light that dance across the sky. We know them as the auroras, the northern and southern lights. Green waves, red streaks, and glowing curtains of color moving silently across the darkness. They are one of the most breathtaking reminders of the invisible battle constantly happening between the sun and our planet. But during a massive solar storm, the sun can send an enormous wave of energy and charged particles toward Earth. When that wave slams into the magnetosphere, it doesn't simply glide around the planet. Instead, it can compress, distort, and violently shake Earth's magnetic field. The protective bubble begins to surge with energy. Magnetic currents ripple through space and even down into the ground beneath our feet. At that moment, the storm is no longer just happening in space. It begins to interact with the technology we rely on every day. And that is when the real problems can begin. If a massive solar storm strikes Earth, the first systems to face the impact are not on the ground. They are high above us. Thousands of satellites orbit our planet every single day, silent, distant, almost invisible. Yet they quietly support many of the systems that modern civilization depends on. Satellites guide GPS navigation that drivers, pilots, and ships rely on. They monitor Earth's atmosphere to provide weather forecasts. They relay television broadcasts and global communications. And they help carry data that keeps the internet running across continents. In many ways, satellites form the invisible backbone of the modern world. But during a powerful solar storm, space around Earth becomes a much more dangerous place. When a coronal mass ejection reaches our planet, it floods near Earth space with high-energy charged particles and intense radiation. These particles can slam directly into satellites. Inside a satellite, delicate electronic systems control navigation, communication, and power. But these electronics are extremely sensitive. A burst of radiation can cause electrical errors, corrupt onboard computers, or permanently damage critical components. In severe cases, a satellite might suddenly lose control, stop responding, or shut down entirely. Solar storms can also heat and expand Earth's upper atmosphere. When this happens, the thin atmosphere at satellite altitudes becomes slightly denser. For satellites orbiting low Earth orbit, this creates extra drag, almost like invisible friction. Some satellites may begin to slow down and drift off their intended paths. If the disturbance is strong enough, a satellite could even re-enter the atmosphere and burn up. Now imagine dozens or even hundreds of satellites malfunctioning at the same time. GPS signals could become unreliable. Navigation systems could fail across large parts of the world. Airplanes flying long distances over oceans might lose precise positioning. Ships traveling through busy shipping lanes could face dangerous uncertainty. A solar storm in space may sound distant, but when satellites begin to fail, its effects quickly reach down to the surface of our planet. But the greatest danger from a massive solar storm may not be in space. It may be right here on the ground, inside the systems that power our cities. Electricity flows through an enormous network of power lines, transformers, and substations that stretch across entire countries. This network, known as the power grid, is designed to deliver energy smoothly and predictably. But during a powerful solar storm, something unusual begins to happen. When the storm strikes Earth's magnetic field, it causes the field to rapidly shift and vibrate. These magnetic disturbances ripple across the planet like invisible waves, and those waves can generate electric currents in the ground itself. Scientists call these geomagnetically induced currents. Normally, electricity in the power grid moves carefully through controlled pathways. But these currents from a solar storm can suddenly surge into long transmission lines, using them like giant antennas. From there, the energy flows directly into large transformers, the massive machines that regulate voltage and distribute power across cities and regions. Transformers are incredibly important, but they are also extremely sensitive to overload. When too much current flows into them, they begin to overheat. Metal components can warp. Insulation can fail. And in severe cases, transformers can permanently burn out. If several key transformers fail at once, entire sections of the power grid can collapse. Cities can go dark. Communication networks begin to falter. Transportation systems slow down. Something similar has already happened before. In 1989, a solar storm struck Earth and triggered a sudden surge in the power grid of Quebec. In just 90 seconds, the entire province lost electricity. Millions of people were left without power for hours. That storm, however, was relatively moderate. Now imagine a storm many times stronger, striking modern infrastructure that is far more connected and far more dependent on electricity. Large transformers are not easy to replace. Some are the size of small buildings, and manufacturing new ones can take months. In the worst-case scenario, widespread transformer failures could lead to long-lasting blackouts across entire regions. A storm that begins on the surface of the sun could end up turning the lights off across the world. Now imagine the consequences spreading even further, because once satellites and power systems begin to fail, another system we rely on every single day starts to weaken. The Internet. To many people, the Internet feels almost magical. Messages appear instantly, videos stream from across the world, and information travels in seconds. But behind this digital world lies a vast physical infrastructure. Enormous data centers store and process information. Millions of cell towers carry wireless signals across cities and landscapes. And deep beneath the oceans, thousands of kilometers of fiber optic cables connect entire continents. All of these systems depend on electricity and stable electronics. If a powerful solar storm disrupts satellites and damages sections of the power grid, the Internet would not simply disappear all at once. Instead, it would begin to fragment. First, satellite communications could become unreliable. GPS timing signals, which many networks depend on, might start drifting. Then, as power outages spread, data centers could shut down. Without electricity, servers cannot process requests or deliver content. Cell towers would soon follow. Most have backup batteries, but these usually last only a few hours. Once those batteries are exhausted, mobile networks would slowly fall silent. Even the massive undersea cables that carry global internet traffic rely on electronic signal repeaters spaced along their length. If those systems lose stable power or experience electrical damage, connections between continents could weaken or fail. The result would not necessarily be a total global blackout of the Internet, but large parts of the world could suddenly find themselves cut off from the digital network that modern life depends on. Banking systems might struggle to process transactions. Air traffic coordination could become more difficult. Emergency services might lose critical communication channels. In just a few hours, the smooth digital flow that connects billions of people could become slow, unstable, and unpredictable. A solar storm that began millions of kilometers away could ripple through space, through power systems, and finally into the global communication networks that keep our world connected. In 1859, Earth was hit by the Carrington Event, the most powerful solar storm ever recorded. Telegraph systems sparked with electricity. Operators received electric shocks. Auroras were visible near the equator. But back then, technology was simple. If the same storm happened today, scientists estimate it could cause trillions of dollars in damage worldwide. The good news is that scientists constantly monitor the sun using space observatories. If a massive solar storm were detected, we might have several hours to a few days of warning. Power companies could temporarily shut down parts of the grid to prevent damage. Satellites could enter safe mode. Airlines could change flight routes. Preparation could reduce the impact significantly. The sun gives us light, warmth, and life. But it also has the power to disrupt our entire technological world. A massive solar storm wouldn't destroy Earth, but it could remind us just how dependent we are on electricity and space technology.